So hello YouTube. I was doing some website design stuff for the upcoming Zig website. But it's 8, so it's time to do the advent of code. So let me where did I put it? Oh no. Okay. Let's go to the advent of code website. Put it here. I think I need to change the title of my stream, so no, wait, where is it? Edit stream info. Advent of code in Zig day 8. And we are, I guess we are ready to go. So let's see. Number 8. Your flight to the major airline hub reaches cruising altitude without incident. While you consider checking the in-flight menu for one of those drinks that come with a little umbrella, you are interrupted by the kid sitting next to you. Oh no. Their handheld game console. What is this linked to? Oh, just to handheld game console. What? Okay. Won't turn on. Ask if you can take a look. You narrow the problem down to a strange infinite loop. In the boot code, your puzzle input of the device. You should be able to fix it, but first you need to be able to run the code in isolation. The boot code is represented as a text file with one instruction per line of text. Each instruction consists of one operation: accumulate, jump, nope, in an argument, a signed number like +4 or -20. Are we? We are emulating code now. Oh no. Oh no. Okay, I've never done this stuff before, so this is gonna be funny. The boot code is represented as a text file. Yeah, I read that. Acc increases or decreases the single global value called the accumulator by the value given in the argument. For example, acc +7 would increase the accumulator by 7. The accumulator starts at 0. After an accumulation instruction, the instruction immediately below is executed next. Jump jumps to a new instruction relative to itself. The next instruction to execute is found using the argument as an offset from the jump instruction. So for example, jump +2 would skip the next instruction. Jump +1 would continue to the instruction immediately below it. And jump -20 would cause the instruction 20 lines above to be executed next. Nop stands for no operation. It does nothing. The instruction immediately below is executed next. Okay, nothing. Increase the accumulator. Jump 4 lines. So 1, 2, 3, 4. So accumulator +1, jump -4. 1, 2, 3, 4. Accumulator +3, jump -3. 1, 2, 3. Accumulator +1, and there we go. We have an infinite loop here too. Maker is gonna do so well. Oh, come on. Like, this is so. If this is all the input, this is not like. This is the one type of thing that where you can probably make do even without Mecha. If that's the input. I mean, yeah, Mecha would be nice, I guess, but you can probably make do with read enum and stuff. We'll see. So these instructions are visited in this order. Okay, this explains 1, 2, 3, 4, 5. Okay, this is doing what I did before. And I guess here it notices that we are in a loop. So the first does nothing, blah, 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 sets back to first. This is an infinite loop. With a sequence of jumps, the program will run forever. The moment the program tries to run any instruction a second time, you know it will never terminate. Right. Why do we know this for this type of language and not for normal computers? Because these can only jump a static amount of time. It cannot jump on something like based on the state of the accumulator. And because of that, it can never like break out of a loop. Okay, so the moment the instruction a second time, blah blah blah. Immediately before the program will run an instruction a second time, the value of the accumulator is 5 in this example. Okay, so we need to count how many. Okay, we need to keep track of the state of the accumulator, and then we need. It's the only state that we need to care about. No, well, for the virtual machine, yes, but then for us, we need to know which instructions we already accessed. The moment we hit the same instruction again, we know we're in a loop, and that's when we stop emulating and we return the state of the accumulator. Yeah, what value is in the accumulator? Holy cow. Holy cow. Okay. Copy. Woof. So open source day 08. And here we want to say, no, we want to open source, I don't know, code day8.txt, I guess. So, someone in RC just asked about docgen. Oh, you mean docgen, the automated doc generation, or docgen, the actual docgen tool that Andrew uses for release notes? So const data is import. Why am I doing? Embed file. Do I want to do this? You know what? I kind of want to do this in Sublime because I have ZLS configured there. I'm gonna be a bad boy and I'm gonna use Sublime maybe today. Well, I still have chat, so see no downside there. OCD, AOC. Sublime, there we go. Force, day 7. So we open day 8. We open day 8. And did I not save here? Okay. We open day 8 and we also open code day 8. Okay. Now remove that. Nice. So embed file code day 8.txt. Oh, thank you. Nice. So next is we have our data. And I think we need to make an array list of instructions. We need a big slice of instructions, and we need to parse it as instructions. And then we run through these instructions. We need to do this because we need to jump back and forth with the instructions. We could try to run stuff as we parse it, but we have also the ability, there are forward jumps, so that would be ultra annoying. So let's just do parse first. Then we start emulating everything. Okay, so well, let's start by parsing, I guess. So var it equals, dude, I haven't done anything. What do you want? Oh no, I enabled this thing. This is gonna kill me. Wait, why is this complaining about this? Oh, this is all okay. Expected expression found. Yeah, dude, I'm typing. Give me a break. God damn it. Var it is std mem.tokenize Buffer data. Delimiter bytes. I guess it's just the new line. No, wait, we can do better. We can tokenize on space and new line. So let's tokenize on both. Because we know that every line is gonna be boop 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 boop. Yep, boop boop boop. So while it.next and this is gonna be token. So each token is gonna be first token is instruction, and I think we can do enum, something int to enum, enum to int. No, std.fmt.parse. How do we parse an enum? I think somewhere we have a parse enum. Is it in meta? String to enum. There we go. Boom. String to enum. So we need this enum. So const instructions is a union, tagged union of what were the instructions that we had there? Well, nop, accumulator, jump. So have I forget the syntax for defining union stuff. I think it's like a struct, right? So have nop, which is of type void, I guess. Then we have, you know what? Maybe it's better if for each we save whatever it's after. It doesn't hurt, so let's just do it. Then we have ack, size, Uzi, size, then jump. Oh wait, no, these are not usize. These are like these are signed iSize. I think these all are signed. So iSize. That's it. I think we don't have other instructions. Yeah, accumulator, jump, and nope. So here we have, can I give you instructions? It's not an enum, but it's a tagged union. Let's hope that meta understands that and it doesn't require me to extract the enum from that type. And the string that we want is token. So first token in instruction, then this gives me a enum. So const instruction. It's this expected what? Found what? No, it should be fine, right? Yes. Okay, this is string to enum. Then second token is value. Const value is std. Why is it so aggressive at trying to parse stuff? I'm not done typing, dude. Oh wait, is this optional? Oh yeah, this is optional. So this must succeed. So value std fmt parse int iSize and it's the next token, I guess. Oh, so we can just do while token. No, yeah, we can do that because we can call it next ourselves. And the base is 10. And then we need an array list. I'm gonna steal some code from yesterday about allocators and stuff. So we have the arena locator. And oh, we need an array list of what? An array list of instructions. And then how do you initialize one of these things? Oh, it's just .init. Okay. So we have our instruction list. Our instruction, oh, this is to be instruction, not plural. Instruction. So what we do then is var instructions is instruction list dot init arena, oh no, %, arena allocator. Area 85, how do you show the auto suggest for the import? What package are you using? I'm using ZLS. I'm using Zig ZLS. Zig Tools ZLS. It's the Zig language server, and it's integrated with Sublime Text 3. So you need to download ZLS, compile, like the instructions tell you how to do everything. You need to compile it and do config. Config will tell you what options you want to enable or disable. And then this tells you which package you need to have in Sublime 3 and how to configure it. So instruction list, we have it. So we parse instruction value, and then for every single thing, instructions dot append, I think, append and time, append slice, assume capacity. No, append what? An instruction. Ooh, how do we do the right case? So I have an enum case. Please tell me the string to enum is smart and not dumb. Please, for the love of God, tell me that string to enum is smart and not dumb. And if it's smart, it will allow me to do a union without having to die. Hopefully. Tag name string to enum. Using comp time string map here is more performable, blah blah blah. Okay. Type info t.enum.fields len string to enum. So are you contiming the data? No, I'm not contiming it. I'm just embedding it just to have it more quickly at my disposal. That's it. Like it's faster to do embed file than to actually read it. So you gotta comp time. I did this already one day. It took like 5 minutes for stuff to compile. Although I could have made it easier, but the point is, the problem still remains though. The problem still kind of remains. It doesn't matter much. The question is, I still have the problem. If I have an enum in hand, what's the right function to build the right case of an union? I think there are some built-ins that can help with that, but I forget which ones they are. Zig bang, what? Documentation. I think there are some built-ins that help with this. Int to enum union init. There we go. This is the same as union initialization syntax, except that the field name is a comp time known value rather than identifier token. Oh no. Are you thinking what I'm thinking? I shouldn't. I really shouldn't. No, come on, there has to be a better way. Maybe Meta has something for us. fields, declarations, field info, field names, active tag. Just the active tag of a tag union. No, I want to make a tag union, please. Oh, yes. Yes. Given a tagged union type, yes, in the enum, return the type of the union field corresponding to the enum tag. Okay, so this is the case moved. We have event. We give it event.moved. Yes. Okay, it's tag payload type. Woo. So tag payload type. So we need to give it a union. So our union is instruction. We need to give it a case, which is instruction. Call it inst. And this cannot be false, it has to be var. And then we do item dot, item dot what? How do we set the value then? Type of e dot moved. Can I do just item? I hate unions. I have to say, I genuinely hate unions. I genuinely hate unions. Can I use like, is there any other thing that I can use, please, to deal with unions? Field index, list. It's tag dog. Yeah, what does it mean? Okay, here's the idea. I just received, I don't know, I just found a jump. How do I set this correctly? I need to grab the active, like, I don't know. Oh, I need to switch to it, I guess. I need to switch over it. And based on what it is, you know what? Yeah, I can do this, I guess. I can do const item. Or actually, no, I don't even need to do this, I guess. I think what I can do is append what? Well, let's switch instruction. And based on what instruction offers, if instruction is .nop, then we return instruction.nop set to value. If it's .ack, we return instruction.nop, no, sorry, .ack set to value, I guess. And if it's jump, we do the same thing with jump. And that should be it. Okay. This kind of works. Let's see. Print Uh, total instructions. Instructions dot count. No. Dot item. What's inside there? Oh no, ZLS, why are you not helping me? What is this shit? No. ZLS, please. We have count, have len, we have items. Items.len, I guess. Okay. Let's see. Big build day 08. Use the client identifier instructions. You're right, because it's singular. Okay, let's see. Expected type constituent found optional constituent. Yep. This has to be there. Accessing accessing field union while field enum while field union is set. Oh, that's annoying. So how do I get the enum case from this? Is it just type info dot union dot enum? No member name enum instruct std union. Yeah, ZLS, can you tell me what it is? ZLS? Instruction. Okay, ZLS is not helping. Yeah, thank you, Lukman, for the compiler told me. So how do I get the enum from type info ZLS? Come on, you were supposed to help me. I feel betrayed. So we need to go in built-in, I guess. And in built-in, we're gonna find how these freaking types are defined. And we're gonna have type info. We're gonna have the case union somewhere. Where is it? Well, it's a strat, but actually, it's gonna be tag union, I think. Union tag type. Tag type. Dot question mark, because there are also untagged union. No member tag type in because it's dot union dot tag type. Okay. Expected type I size found parse error. Oh yes, need to try. Error is ignored. Consider try or catch. Okay, try. Total instructions 647. Okay, we finally got the parsing done. So we are accumulating all the instructions. Then, now we need to run this stuff. I guess Game Boy is a struct that has accumulator, which is a usize. Is it? I'm not even sure. iSize. No, it's probably not. It is signed, I think, and it starts at 0. And then we have in the program counter, like we have the instruction that we are running. And the program counter is a usize and starts at 0. And that's our thing, right? So now we run the Game Boy. How do we do this? Interesting. We have the instructions. We have a Game Boy. Well, we need to make a Game Boy. So var gb equals Game Boy. So we make a Game Boy. And I guess what I kind of want to do is start from the first instruction, of course. So I'll do, these instructions, it's an array list. So let's call it inst list. Let's rename this to, actually, no, wait. I want to rename this, but LSP, do your work, rename symbol, inst list. Thank you. So now what we want to do is const instructions equals inst list instruction list dot items. This gives me a slice. So next, what I'm going to do, I guess, is instructions 0, the first instruction, dot let me think about it. Dot run, dot next. So dot next, and we give it the Game Boy. We give it a reference to the Game Boy. I need to make this next method inside the thing. And I also want to do this while I've never seen an instruction before. So I want to see the scene instructions. I could put this, I guess, inside the Game Boy itself. But I won't, because I can do either way. But I want to do this outside, I guess. So I'll need to do a var. Actually, let me put this. This can go away. We have instructions. So var scene is a array of booleans set to false. How many of those instructions? Oh wait, that's an array, and this length is known at runtime, but I can cheat. I know the number. I'm like Dr. Strange. I've seen every possible value, which is only one. Because we're ever gonna have one input. So we make 647 of those. Yeah. Oh wait, what's the last one? Oh, but we don't care. It's an infinite loop. We know there's no last one. So 647, they're all set to false, and we keep doing so. Last var last instruction equals 0. It's a usize. And while last instruction is while we haven't seen the last instruction, what do? We do last instruction equals instructions last instruction of next, passing in the Game Boy, which is what we were doing before, but this I think it can be our continuation thing. And actually I don't need the graph parentheses, like the curly braces. And inside, what we do? Well, all we have to do inside is say scene last instruction is true. So we're gonna break from the while loop, and let me think about it. So last instruction keeps changing, but the problem with last instruction is at the end of everything, last instruction is gonna be not the one. Let me think a bit. Oh, I don't care about the last instruction itself. What I care about is the accumulator. So finally, we say print p.accumulator equals something, and that's our gb.accumulator. We're not even lying. That's precisely what it is. Okay. This seems This seems okay. Boom, 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 boom. Now we need run or next. Yeah, we need next in here. So function next self is a instruction, and then we have a Game Boy, which is a pointer to a Game Boy. And what we return is a usize. Oh shit, wait. Hmm. Plus equal. We return a relative movement. Yep. We return a relative movement. So actually these are e size. Because we can also go back. We kind of need to go back at one point for sure. Okay. So we change last instruction. So the first time we start with, from the first instruction, we're going to have index 0. And now it depends on what we are. If you are a knob, you just return 1 because we want to move to the next instruction, and that's it. If it's a jump, we return, we need to capture what's stored inside the jump, and we return it because that's how much forward we need to move. And if it's an accumulator, we need to capture, and then we need to modify the Game Boy. Here we need a column. So we need to do gb.accumulator plus equals that value, and then we return 1, I believe. Yeah. Is this really it? I doubt everything works fine first try. But you know what? YOLO. Let's be optimistic. It kind of seems it's doing everything it needs to do. Oh yeah, programming. Yeah, incompatible types U size and I size. How do we do this? How do we do this? How do we subtract from that? Can I make this like a smaller number, like I16? Is this gonna work? On I size. I mean, it's not gonna give out gigantic numbers inside of here. So, is this smaller thing compatible? Except that I16 found I size. I guess it's here. No, it still complains about that too. How can we do this? Can we make this not U size? Can we make this like I size? Is this going to work? Expected U size found I size. Note, unsigned 64-bit cannot represent all possible 64-bit values. Wait, what? I know, but okay, please, Zig, how do I make you stop complaining about this? Um, int cast. Oh, you know what? Let me wait. Let me do the int cast somewhere else. So let me. Oh no, this was okay. Okay, let's keep the e size. So everything is fine except the sum. Now it's complaining about the sum. Can we somehow force a cast here? Like as no int cast to usize. No. Oh, god damn it. Why can't I subtract stuff? Why can't I add with a negative number to this? Come on. How do you subtract from a usize another value? Not if I int cast this to a smaller thing. Hmm. I just don't get it. Why is this so annoying to do this? std.math.add. Oh, but they have to be of the same time for add to work. That's annoying. Anybody in chat have any suggestion on how to convince Zig to let me kinda do this? Incompatible types, I know, but how do I do this sum? So I can do less instruction equals wrapping addition. I don't know if that works. I don't think that works either. Yeah, no, it's not wrapping. It's not it's a type thing. Like wrapping addition, you just need a percentage. That's easy. Last instruction. So, okay, now I simplified the problem. Now the problem is that I need to make this thing work out. How do we make this thing work out? You know what? I can do as or int cast I size less instruction. And I think this is almost there. Or you know what? Int cast I30, I16. Int cast I16. I don't know. There are probably better ways of doing this. And now I think I need an outer cast. Yes. This is not super cute, I would say. Okay. And he gave me an accumulator state. Is this it? Yeah, Holy Ugly Way works. Yeah, I mean, I'm not super clear, like in my mind. Like if you ask me to enumerate some of the rules about numbers, I can probably enumerate them, but they're not super clear in my mind about how they interact. Now that I'm thinking about it more clearly, I'm not just trying to get it to compile. I know that if you try to mix signed and unsigned, they mess up. If you try to, like, you need to convert them. You need to convert the representation. You can just mix the numbers directly. Anyway, this works. So let's see if that number is correct. 1949. Ooh. I would say it's almost first time. No, bitcast is exactly what I don't want because I need the conversion to manipulate the bits. It's not just a way of reinterpreting the bits. I think, actually, I'm not even sure. Maybe we could get away with it. In a general sense, I think that's not what I want, but maybe it could work. It could have worked this way. In any case, right answer. It works. So it was madness with designing stuff, but I'll say this is my fault. I don't know how to properly do this stuff with numbers, and I have to admit in C, it happened to me in the past that I messed with signed and unsigned stuff, and I got garbage because of that. So Zig is right in trying to prevent me from doing this type of garbage. The problem is I don't remember what the proper route is for making this work. In any case, hey, everything else worked first try. What the hell? Nice. So continue to part 2. First half of the puzzle is complete. Part 2. After some careful analysis, you believe that exactly one instruction is corrupted. Somewhere in the program, either a jump is supposed to be a nop, or a nop is supposed to be a jump. No accumulator instructions were harmed in the corruption of this boot code. The program is supposed to terminate by attempting to execute an instruction. The program is supposed to terminate by attempting to execute an instruction immediately after the last instruction in the file. By changing exactly one jump or nop, you can repair the boot code to make it terminate correctly. Whoa? So for example, consider the following program from above. If you change the first instruction from nop plus 0 to jump plus 0, it would create a single instruction infinite loop, never leaving that instruction. If you change almost any other jump instructions, the program will still eventually find another jump instruction and loop forever. However, if you change the second to last instruction from jump -4 to nop -4, the program terminates. The instructions visited in this order, blah, blah, blah. After the last instruction, the program terminates by attempting to run the instruction below the last instruction in the file. With this change, after the program terminates, the accumulator contains the value 8. Fix the program so that it terminates normally by changing exact one jump to nop or nop to jump. What is the value of the accumulator after the program terminates? Wow. This is a big step up from before. Okay, I think it's doable, but, well, it's certainly doable. I think I can make it work, but it requires a bit more machinery, I guess. So now we have one Game Boy to keep track of the instructions seen, but now we need more Game Boys, and we need to keep track of the instructions that we modified, and we need to copy these instructions from the master copy every single time because we want to start from a fresh thing. We basically need to keep an index. Every time we encounter a nop or a jump, we flip it before executing it, and we need to keep track of which ones we flipped. And then everything probably goes to shit afterwards, but then the next loop, when we try again, we know at which instruction index up to which instruction index we have tried to alter the input, and then we only try to alter starting from there. So it shouldn't be a big change from what we have now. So what we want to do here is I'm gonna go ahead and put a while true, and we do this stuff inside a while true. And what we want to do here is at every start we have a new Game Boy, yes. And at every start instructions, it's a copy. So how do we copy a slice? std.mem.copy. Okay, we need to allocate. Sorry, is copy what? Type destination source. So type is instruction. Destination is, I guess, instructions. And the original source is what's in the list. Then we do var instructions of type slice of instruction is undefined. So every time we start with an empty, let me think about it. No, instructions needs to be, let's make it an array. Yeah, it's an array of instructions. It's on set. Every single loop, copy there, pointer off. We copy there the instructions from the original, from the master, and we run everything. So this should still work as before. Or maybe not. Maybe everything. Oh no, there's a while true outside. Okay, yes, sure. Okay, so we have two whiles. We need to label this. How do we call the outside? How do we call the other one? Hack, since we're hacking the code. So here, what we want to do is, if we found, so I might as well, okay, no, let me first see that it works as it was working before. So the way it works is that after we are done with this while, we want to break from the outer loop. Okay, so this counteracts the while true. Oh no, GB needs to be declared outside. Okay, so var GB is a Game Boy, and every time we start, we set, well, you know what? Type Game Boy, and we set it to undefined. Inside every single time we set it. Okay, so now this should work. Okay, as I was saying, this is the hacking while loop. And in here, the condition was, if we try to execute, if last instruction is greater or equal than instructions.len. So if we're trying to execute something outside of our range, we want to break hack because we are done with the hacking. That's our success condition. We break the outer label and we print stuff. Now, this wasn't the case now. So what we now need is var hacked up to the usize. It's the index to up to which we modified instructions. So in the while loop, when we get the next instruction, what I want to know is if last instruction is greater than hacked up to. So if it's an instruction that we never hacked before, which basically is all of them in the beginning, we want to do, how do we want to do? We want to say that if actually switch no, that's a problem. That's a problem. These cannot be in here anymore. Because we need to see what it is. So this needs to become next instruction. Because we need to modify stuff before. I mean, we could wire stuff in here and like modify on the fly while we are executing, but I think it's better to leave this stuff outside. So now we need next instruction, and we need to do last instruction, which basically is current instruction becomes next instruction. Let's change this to current instruction. Okay, so if next instruction, wait, LSP, I think LSP failed me. That rename didn't rename everything. What the hell? Okay, let's leave it as that. So if next instruction is greater than hack2, then we want to switch. What's in there. Var next is a pointer to instructions. Next instruction. Which next? If next is hack, you don't do anything. If next is jump, we do next dot star equals to instruction case dot nop. Let's capture also the value. Nop set to value. And if it's a nop, you make it a jump. What am I missing? I think I'm missing I'm missing this. Expected semicolon. Did I not put a semicolon here? I did not put a semicolon here. Okay. We maybe have these things on a separate line, like this, maybe. No. Okay, ZFMT disagrees. Fine. So we swap the instruction and then we set act up to next instruction. We set it to the new index. The only thing that we're missing now is that with this, we keep changing instruction, we keep flipping them, but we only want to flip one per loop. So here, we need one final thing, which says var act this loop starts at false, and here we set to true. Act this loop set to true, and we check it. If not, hack this loop, and if we never hacked it in this loop and we are reading an instruction that we have never hacked, wait, this is not correct. When do you break? I have a break here. If we reach an instruction that is like, if we the text from the text here from AOC says that our break condition is trying to execute an instruction that doesn't exist. It's in their case they say it's one more than the ones that they exist. In my case, I made this condition less tight. So I said if you're trying to execute an instruction that doesn't exist, we're outside. So here's the problem with act up to. Act up to has the downside that if we jump to one, like it cannot be just a threshold, like a water level thing, because we could be hacking, we could be jumping back and trying to need to change an instruction that we jumped over before. So it cannot just be a threshold. It needs to be an array. It needs to be this. It needs to be this. It needs to be an array of booleans. It needs to be an array of booleans. And we only do this if we've never hacked the next instruction. And in here, we set hacked, next instruction to true, and now we're good. Hacked starts all false, we start flipping bits. And we only flip if we never flipped it before. And this should be it. Oh, the question was when you are infinitely looping. Oh, sorry. Yeah, you're right. Yeah, this is consuming a bunch of brain power from me, so I'm not looking at chat as much as I should. Error. Else prong required for switching instruction. For switching type pointer to instruction. No? Oh, I mean, okay. Do you prefer this? I mean, that's not wrong. And that is very, very suspicious. I don't like this. What? Is it really possible? I need prints here. I don't trust what's happening here. So also let me do this. I mean, this should be good, but let me do this so that it's less convoluted. Oh, wait, this stupid breakdown here. I forgot to delete it. Okay, now it's gonna try a bit more. I should probably have print. Wait, let me add some prints. So every time we start the loop, print new hacking loop. And then here we say flipping, and I want an index. Next instruction. And here we do looping detected. Loop, I guess. Loop detected. Okay, let's see if the print stuff that we like. New hacking loop, loop detected, new hacking loop. Why are we never trying to change an instruction? We keep complaining about loops without changing instructions. Why we never flip stuff? Okay, let me read the comments. There's still a break at the end of the hack. Oh, yep. They moved it. Okay, so why are we never trying to flip stuff? We have seen, which is fine. We are setting last instruction to next instruction. You know what? I kind of think. I think something changed. I think I changed something here, and that caused problems somewhere. So print next. I think that's where I introduced the bug. Okay, show me the next instruction then. Okay, no, it's doing stuff. So this is not wrong, but why? Why are we never changing any instruction? Okay, so we enter in here, we keep looping. If never hacked this loop and oh, and not hacked next instruction, we are kind of missing a pretty important not. Yep. Index out of bounds. That kind of makes sense. I mean, that's okay. Why are we not catching? Oh, because it's next instruction. Okay. Now this has to become next instruction. And I think like this should go here. Yeah, okay. So now we should be good. There we go. 2092. Let me see flipping stuff. Okay, turns out that the right move was to flip 265. At least. Wait, no. Okay. Yay, right answer. Almost first try. Like, well, first try with the answer. So we got the correct answer right away. What happened here that made me mess up? I think I wasn't super clean in readapting the code. It wasn't super hard. I missed like this condition. I had the right realization that the water level counter wasn't enough. I needed like more precise stuff. I just messed this not condition, which caused me to never enter here. So I need a bit of, I guess, print debugging. I would probably have made done, like I could probably have solved it maybe even quicker with a bit of debugging, but whatever, print debugging. Good enough. Oh yeah, wait, number 9. Oh, that was fun. Like the virtual machine stuff is fun. It's not parser heavy, finally. Like again, parsing took me more time than I wish it took. But the problem for me was that I was trying to metaprogram my way around strings, enum cases, and stuff. And what I was missing is this. There is no syntax to quickly say something like var instruction or whatever it is equals instruction dot magic instruction and then dot magic something to which you give inst and then you can set it to val. Like this syntax doesn't exist. I was searching for something of this sort. Maybe not with this exact syntax, right? Maybe something like var foo or whatever it needs to be, std.meta dot make union. I don't know, make union. You give it instruction, you give it instr, right? You give it the type, you give it the case, and then you give it the value, and then it makes one for you. And maybe we should have something like this. Actually, this is nice to have. But if you don't have something pre-made, the only approach is this. You need to switch the enum and then create literals yourself. But this is so much typing. I think there is something. Then let's find it. But I'll let you know when I get there. Okay, looking forward to that then, Matt. So this took me some time. But after I went past this hurdle, then everything else was pretty easy, I would say. Like, the machine just needs a next thing. It's easy. Side effects get saved into our state thingy. Oh, look, the program counter it's not even necessary because we never change it. We just pass it around as an argument in the outside thing. And it turns out that, I mean, Fine. You know what URC needs? Don't print the name or repeat the messages. Dude, you have no idea how hard this is probably in IRSSI. No, it is possible. It is possible. It is possible. There's a variable that keeps track of the... Okay, you know what? Let me cut the recording here for YouTube. So, hi, hello YouTube. Hope you enjoyed this video. See you tomorrow again. It's time to hack IRSSI, I guess. So, bye.